Hello and welcome back to Unit 7. In this part of Unit 7, we're going to introduce the concept of kinetic energy. To really understand what kinetic energy is, it'd be really useful to have a definition of energy. The bad news is that the definitions that are out there are not that good. So if we go and look at dictionary.com, here is what it says. The capacity for vigorous activity or adequate or abundant the ability to act, lead others, affect. None of these are really great definitions. There used to be, if you click see more. Oh, here's the physics definition, the capacity to do work. Oh, that's helpful. If we go over to the other website, here we're at the Canadian Science and Technology Museum. What energy is the ability to do work, which is the ability to exert a force causing a displacement. Okay, that's a little bit more helpful maybe. If you go and look at your textbook, as far as I can tell, it's not really defined. Instead, it just kind of uses the word, defines the word work in terms of energy. So I wish at this point that I could say, here is a really good definition of energy, but I can't. It's not like force where you can feel or a push or a pull. It's not like velocity where you know how fast you're moving, or acceleration where you know how fast or how much your velocity is changing per given amount of time. Energy is just not that way. You've seen the definitions are out there, so you're going to have to internalize and come up with something that works for yourself, and it's probably going to be a feeling or a kind of a nebulous thing that is really tough to put into words. And the best I can tell you is welcome to the boat. We are all in the same predicament when it comes to trying to make this definition. But regardless, whatever energy is, kinetic energy is energy contained in motion. Energy contained in motion. So it is defined, kinetic energy, as 1/2 times the mass times the velocity squared. And yes, that is velocity squared. You're like, but velocity is a vector. Yeah, velocity is a vector. So if I want velocity squared and I'm given the vector of it, then I have to take the dot product of it with itself. The other thing you can think of is v squared would be the magnitude of the velocity squared. Both of those work. Let's do a quick example. So here we have a Honda Civic with a mass of about 1,300 kilograms, roughly. I mean, it's not a huge car here. And it does have a velocity in vector format. So what is its kinetic energy? So we know that the first thing we need to do is calculate v dot v. So we get v squared. And that will be 25 times 25, 25 squared, plus 15 times 15. And that will have units of meters squared per second squared. And if you put that all into a calculator, you get 850 meters squared per second squared. Now we can calculate the kinetic energy as 1/2 times the mass times the velocity squared, which is 1/2 of 1,300 kilograms times 850 meters squared per second squared, which works out to be 552,500 joules. This concludes this part of Unit 7.